Hello, math learners! Our lesson for today is about circular functions. The learning objectives are: you are going to illustrate the unit circle and the relationship between the linear and angular measures of a central angle in a unit circle. Convert degree measure to radian measure. Illustrate angles in standard position and coterminal angles. Illustrate the different circular functions. Use reference angles to find exact values of the circular functions. This is the Learning Pocket concept map. We are going to tackle the basic concepts of geometry and trigonometry, the unit circle, and the 6 circular functions and ratios. Let us have first some basic concepts of geometry and trigonometry. Let us have first the derivation of the conversion unit in expressing a degree measure to radian measure or radian measure to degree measure. Let us recall the circumference of a circle, which is 2 pi r. Now, there are 2 pi radians in a complete rotation of 360 degrees. So, when we have 2 pi radians is equal to 360 degrees and divide both sides by 2, then what we have is pi radians equals to 180 because 360 divided by 2 is 180. And then divide again both sides by pi, then what we have is 1 radian, which is equivalent to 180 over pi. For example, convert degree measure into radian measure. So, if you are given 45 degrees, all you have to do is to multiply 45 degrees by pi over 180 degrees, and then cancel degree unit, then you will have pi over 4. Just reduce 45 and 180. So 45 degrees is equivalent to pi over 4 radian, or simply pi over 4. Now, expressing 60 degrees in radian, we will have 60 degrees times pi over 180 degrees. And 60 degrees pi over 180 degrees, cancel degree unit, then you will have pi over 3 radian. Another example. So by this time, expressing radian to degree measure. So given pi over 2, and we are going to convert this or express this in degrees. So for the solutions, multiply pi over 2 by 180 degrees over pi. And by this time, you cancel pi. So 180 degrees over 2 is equivalent to 90 degrees. Therefore, pi over 2 is simply equivalent to 90 degrees. Another example, pi over 4. And we are going to change this into degrees. So for the solutions, we have pi over 4 times 180 degrees over pi. Cancel pi, so 180 degrees divided by 4 is 45 degrees. So pi over 4 is just simply equivalent to 45 degrees. Now let us recall angle in standard position. An angle is in standard position if its vertex is located at the origin and its initial side extends along the positive x-axis. And this is the illustration. This is the initial side along the x-axis, and this is the terminal side. We also have the positive angle and the negative angle. If the angle is measured in a counterclockwise direction, from the initial side to the terminal side, the angle is said to be a positive angle. If the angle is measured in a clockwise direction, the angle is said to be a negative angle. So for example, a positive angle equivalent to 45 degrees, and by this time we use theta to represent an angle. 45 degrees is equivalent to pi over 4. And also we have a negative angle which is equivalent to negative 45 degrees, or simply equivalent to negative pi over 4. And this is the illustration. For a positive 45 degrees, you measure from the initial side to the terminal side, and the direction is counterclockwise. And for a negative angle, negative 45 degrees, from the initial side, measure 45 degrees in clockwise direction. The blue ray will represent the terminal side. Now, drawing an angle in standard position always starts the same way, and draw the initial side along the positive x-axis. To place the terminal side of the angle, we must calculate the fraction of a full rotation the angle represents. We do that by dividing the angle measured in degrees by 360 degrees. So for example, if you are going to draw a 90-degree angle, or pi over 2, you start with the initial side. So from here, and 90 divided by 360 is equivalent to 1/4. So the terminal side will be located on the positive y-axis, which is equivalent to 1/4 of the rotation. And in drawing a 360-degree angle, you start with the initial side here on the positive x-axis, and you do a complete rotation that's equivalent to 1 rotation, which is 360 degrees. So meaning 360 divided by 360 is equivalent to 1. So it will give you 1 rotation. So meaning the initial side as well as the terminal side coincide with each other. Let us also have the quadrantal angles. An angle is a quadrantal angle if its terminal side lies on an axis. Since we define an angle in standard position by its terminal side, we have a special type of angle whose terminal side lies on an x-axis. This type of an angle can have a measure of 0 degree, 90 degrees, 180 degrees, 270 degrees, or 360 degrees. So this is the illustration. For a zero angle, initial side coincides with the terminal side. For a 90 degree, the initial side is here, and you end up on the y-axis, and this is now the terminal side. For a 180 degrees, the initial side is on the x-axis, and the terminal side by this time lies on the negative x-axis. And for a 270 degrees, the initial side is here on the x-axis, and the terminal side lies on the negative y-axis. Let us also have the reference angle. Basically, any angle on the xy plane has a reference angle, which is always between 0 and 90 degrees. The reference angle is always the smallest positive acute angle that you can make from the terminal side of an angle with the x-axis. A reference angle always uses the x-axis as its frame of reference. To find the reference angle, refer to the table below. In the first quadrant, the measure of the angle is between 0 degrees to 90 degrees. So the reference angle is simply equivalent to the given angle or to the given measure of the theta. For the second quadrant, that is between 90 degrees to 180 degrees, the measure of the reference angle is 180 degrees minus the given angle. For the third quadrant, the measure of the angle is between 180 degrees to 270 degrees. So to find the reference angle, the given theta minus 180 degrees. And for the fourth quadrant, so the measure of the angle is between 270 degrees to 360 degrees, then the measure of the reference angle can be taken by subtracting 360 degrees and the given angle. For example, find the reference angle of the following angle measures: 65 degrees, 120 degrees, 250 degrees, and 315 degrees. So this is the illustration. For a 65 degree given angle, the reference angle is equivalent to itself. So reference angle is also 65 degrees. For a 120 degree angle, the reference angle is 60 degrees. So this location is the location of the reference angle. That is 180 minus 120 degrees. So equivalent to 60 degrees. Take note, the reference angle is between the x-axis and the terminal side. For a 250 degree angle, the reference angle is this part, so terminal side between the negative x-axis, and it is equivalent to 70 degrees. That is 250 degrees minus 180 is 70 degrees. And for a 315 degree angle given, the reference angle is 45 degrees. Simply subtract 360 by the given angle, which is equivalent to 315 degrees. So the answer is 45 degrees. So the location of the reference angle is between the terminal side and the x-axis. So again, if the given angle is 65 degrees, the reference angle is 65 degrees. 120 degrees given, so the reference angle is 60 degrees. 250 degrees given angle, so the reference angle is 70 degrees. And 315 degree given angle, the reference angle is 45 degrees. And they are all positive acute angle. And take note, we're using theta, and theta is the 8th letter of the Greek alphabet and is used to represent an angle. Let us also have coterminal angles. Coterminal angles are angles in standard position, angles with the initial side on the positive x-axis that have a common terminal side. For example, 45 degrees, negative 315 degrees, and 405 are all coterminal. For example, find a positive and a negative angle coterminal with a 45 degree angle. So for the illustrations, this is the 45 degree angle, and for a negative angle coterminal to 45, so you rotate from the initial side here clockwise direction until here, and this is the terminal side. You have to end up with the terminal side, and the measure is negative 315 degrees. And for a positive coterminal of 45, here this is 45, so you make one more rotation. So from the initial side until here, that's one rotation here, that's 360, and you move another 45 degrees to end up with the terminal side. So 360 plus 45 degrees is equivalent to 405 degrees. Therefore, the answers are negative 315 angle for a negative, and that is taken by 45 degrees minus 360, and you have negative 315. And for a positive coterminal angle, which is 405, that is taken, 45 degrees plus 460 is equal to 405 degrees. And these two are coterminal with a 45-degree angle. Example number 2. Find a positive and a negative angle coterminal with pi over 3 angle. So by this time, the given is in radian measure. So if the given is in radian measure, you give also the answers in radian measures. And this is the illustration. Given pi over 3, that is equivalent to 60 degrees. So for a negative coterminal of pi over 3, it is equivalent to negative 5 pi over 3. And for a positive coterminal, it will give you 1 rotation plus pi over 3. So from here until here, that's 1 rotation, and 1 rotation is 2 pi plus pi over 3, it will give you 7 pi over 3. For the solutions, we will have, for a positive coterminal angle, that is pi over 3 plus 2 pi, then find the LCD, which is 3. So 3 divided by 3 is 1 times pi is pi. 3 divided by 1 here, it's 3 times 2, it's 6. So 6 pi. So pi plus 6 pi is 7 pi. 7 pi over 3. That's the positive coterminal. For a negative coterminal, so you will have pi over 3 minus 2 pi. So find the LCD, and it will give you negative 5 pi over 3. So again, the answers are 7 pi over 3 and negative 5 pi over 3. They are the coterminal angles of pi over 3. And take note, there are infinite number of positive and negative coterminal angles, and it is according to the number of revolutions or rotations. Next, let us recall the special right triangles. There are two very special right triangle relationships will continually appear throughout the study of mathematics, namely the 30-60-90 triangle and the 45-45-90 triangle. In a 30-60-90 degrees triangle, the measure of the hypotenuse is 2 times that of the leg opposite the 30-degree angle, and the measure of the other leg is square root of 3 times that of the leg opposite the 30-degree angle. The sides are in the ratio of 1 is to square root of 3 is to 2. And this is the illustration. So 30 degrees, the opposite side is equivalent to 1. For a 60-degree angle, the opposite side is equivalent to square root of 3, and the hypotenuse is 2. In an isosceles right triangle, the angle measures are 45 degrees, 45 degrees, 90 degrees. And the side lengths create a ratio where the measure of the hypotenuse is square root of 2 times the measure of each leg. The congruent sides and the hypotenuse are in the ratio of 1 is to 1 is to square root of 2. So this is the illustration. 45 degrees, the opposite is 1. Here is also 45, the opposite is 1. And the measure of the hypotenuse is square root of 2. And the hypotenuse can be solved using the Pythagorean theorem. Now let's make the hypotenuse equal to 1 in each of the triangles. Using the appropriate ratios, the new side lengths are in a 30-60-90 triangle. Then we will have this side measures 1/2, which is opposite to the 30-degree angle. This side is square root of 3 over 2, opposite to the 60-degree angle. And the hypotenuse is now equivalent to 1. In a 45-45-90 triangle, so the opposite of 45 degree is square root of 2 over 2, and also the other side is square root of 2 over 2 because the hypotenuse is equivalent to 1. These triangles can now fit inside the unit circle where the center is at the origin and the radius is equivalent to 1 unit. So The first one, we have a 30, 60, 90 triangle. So this side is equivalent to square root of 3 over 2, and the other is equivalent to 1/2. The radius or the hypotenuse is 1. So the coordinates of this point, we have square root of 3 over 2 for the x coordinate and 1/2 for the y coordinate. For a 45, 45, 90 triangle, this side is equivalent to square root of 2 over 2, and also this side. So it will mean that the coordinates of this point is square root of 2 over 2, and also for the y coordinate is square root of 2 over 2. And if the reference angle is 60 degrees, this side now is 1/2, and this side is square root of 3 over 2. So this will mean that the coordinates of this point on the circle represented by P is 1/2 for the x coordinate and square root of 3 over 2 for the y coordinate. And let us have now the solutions for the coordinates of the points. Using the equation of the circle x squared plus y squared is equal to 1, where the center is at the origin with coordinate 0, 0, and the radius is equivalent to 1 unit, all we have to do is to substitute the given value and solve for the unknown. So for example, if y is equal to 1/2, then substitute 1/2 to y, then take the square, that is equivalent to 1/4. And transpose 1/4, it is 1 minus 1/4. And find the LCD and simplify, then we will have 3/4. And to solve for x, we have to extract the square root of 3/4, and that is equivalent to square root of 3 over square root of 4. And square root of 4 is 2. That is why the value of x is square root of 3 over 2. Next, if x is equal to 1/2, we are going to change x into 1/2. Take the square, that is 1/4. And transpose, so we have now 1 minus 1/4. Take the LCD, we will have 3/4. Again, to solve for y, we are going to extract the square root of 3/4. Then we will have square root of 3 over square root of 4, which will give us, again, square root of 3 over 2. So the value of y is square root of 3 over 2. Next, if x is equal to square root of 2 over 2, then we are going to change x into square root of 2 over 2, then take the square. So we have square root of 4 over 4. Square root of 4 is 2 over 4, and this is 2/4 can be reduced into 1/2. Then transpose 1/2, then we will have now 1 minus 1/2. So that is equivalent to 1/2. Take the square root of 1/2, so square root of 1 over square root of 2, which is equivalent to 1 over square root of 2. Then we have to rationalize the denominator by multiplying square root of 2 over square root of 2. So what we have now is y is equal to square root of 2 over 2, because square root of 2 times square root of 2 is square root of 4, and square root of 4 is 2. And to check, at point P with coordinates 1/2 and square root of 3 over 2, using the equation of the circle with radius 1, we are going to substitute 1/2 to x, square root of 3 over 2 to y. And simplify, so we have 1/4 plus 3/4, and 1/4 plus 3/4 is 4 over 4, wherein it will give us 1 equals to 1. And this is a true statement. For the other solutions, you do it yourself. Now take note, every point on the circle satisfies the equation. So the unit circle where the center is at the origin and the radius is equivalent to 1 unit with a 30, 60, 90 triangle, and the reference angle is 30 degrees, we have this coordinates of the point. Square root of 3 over 2 and 1/2. And for a 45-degree reference angle, we have square root of 2 over 2 and square root of 2 over 2. And for a 60 reference angle, we have 1/2 and square root of 3 over 2. Let us have now the unit circle. The graph of the equation x squared plus y squared equals 1 is a circle in the rectangular coordinate system. The circle is drawn in a coordinate system where the circle's center is at the origin and has a radius of 1. This circle is known as a unit circle. So this is how a unit circle looks like. Have here the measurement of angles in degrees. Then next we have in radian measures, and these coordinates are the coordinates of the points of special angles. And these coordinates are the coordinates of the points on the circle representing the special angles. The x and y coordinates for each point along the circle are defined by using a unit circle, and they are often called circular functions. Let us have now the circular functions. Circular functions are also called trigonometric functions, and the study of circular functions is called trigonometry. Circular functions are defined such that their domains are sets of numbers that corresponds to the measures in radian units of the angles. These functions are called circular functions because radian measures of angles are determined by the lengths of arcs of circles. The cosine of the angle would be the x coordinate, and the sine of the angle would be the y coordinate. So in this illustration, if the center is at the origin, the hypotenuse or the radius is equivalent to 1, then this point represented by P with coordinates xy, this x coordinate can be called as the cosine theta, and this y coordinate can now be called as sine theta. The functions describing the horizontal and vertical positions of a point on a circle as a function of angle, the cosine and the sine, and those functions derived from them, namely tangent, cotangent, secant, and cosecant. And these 6 are what we call the 6 circular functions. So let us have now the 6 circular functions and ratios. Suppose theta is an angle plotted in standard position, and P with coordinates xy is the point on the terminal side of theta which lies on the unit circle. Circular or trigonometric ratios represent relation between two sides of a right triangle. These are referred to as ratios since they can be expressed in terms of the sides of a right-angled triangle for a specific angle theta. In this illustration, this angle represented by theta is the reference angle, and this side is what we call the opposite side of theta. This side here with X mark is the adjacent side of theta, and this side, which is opposite to the right angle, is what we call the hypotenuse and represented by R. So the 6 circular functions are sine, cosine, tangent, cotangent, secant, cosecant, and the abbreviation is sine, cosine, tangent, cotangent, secant, cosecant. So for the definition, we have for sine, opposite side of theta over hypotenuse, and then you have the adjacent side of theta over hypotenuse for cosine. And for tangent, we have opposite side of theta over adjacent side of the angle. And for cotangent, we have adjacent side of the theta over the opposite side of the theta. And cotangent is the reciprocal of tangent. Secant is the hypotenuse over adjacent side of theta. And this secant is the reciprocal of cosine. And lastly, we have cosecant. It's the ratio of the hypotenuse over the opposite side of the angle. And the ratio equivalent in terms of x, y, and r. For sine, we have y over r, wherein r is equivalent to 1, so sine theta is just simply equivalent to y. For cosine, we have x over r, and r is equal to 1, so cosine theta is just simply equivalent to x. Tangent is y over x, so we have tangent theta is equal to y over x. Cotangent is x over y, so cotangent theta is x over y. We just simply interchange the position of x and y because cotangent again is the reciprocal of tangent. For secant, r over x. We can have secant theta is equal to 1 over x because r is equal to 1 unit. The reciprocal of x here is 1 over x. And for cosecant, we have r over y. Or simply, cosecant theta is equal to 1 over y since r is equal to 1 unit. Or the reciprocal of y here is 1 over y. Let us have the definitions of the 6 circular functions and ratios. Cosine of theta denoted by cos theta is defined by cosine theta is equal to x. It is the ratio of the adjacent side of the given angle and the hypotenuse of a right triangle. Sine of theta denoted sine theta is defined by sine theta equals y. It is the ratio of the opposite side of the angle and the hypotenuse of a right triangle. Tangent of theta, denoted by tan theta, is defined by tan theta is equal to y over x, provided x is not equal to 0. It is the ratio of the opposite side of the given angle and the adjacent side of the given angle of a right triangle. The word tangent comes from a Latin meaning to touch, and for this reason, the line x is equal to 1 is called a tangent line to the unit circle since it intersects or touches the circle at only one point, namely the point with coordinates 1, 0. For cotangent of theta denoted by cot theta is defined by cot theta is equal to or cotangent theta is equal to x over y, provided y is not equal to 0. It is the ratio of the adjacent side of the given angle and the opposite side of the given angle of a right triangle. Secant theta, secant of theta denoted by sec theta is defined by secant theta equals 1 over x, provided x is not equal to 0. And it is the ratio of the hypotenuse and the adjacent side of the given angle of the right triangle. The word secant means to cut. So a secant line is any line that cuts through a circle at 2 points. The line containing the terminal side of theta is a secant line since it intersects the unit circle in quadrants 1 and 3. With the point P lying on the unit circle, the length of the hypotenuse is 1. Cosecant of theta denoted by cosecant theta is defined by cosecant theta equals 1 over y, provided y is not equal to 0. It is the ratio of the hypotenuse and the opposite side of the given angle. Now, the trigonometric ratios are sine, cosine, tangent, cotangent, secant, and cosecant. The standard angles for these trigonometric ratios are 0 degree, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And this can also be represented in the form of radians, such as 0 radian, pi over 6 radian, pi over 4, pi over 3, and pi over 2, respectively. These angles are most commonly and frequently used in trigonometry. Learning the values of these trigonometry angles is very necessary to solve various problems. Now, this quarter of a unit circle wherein this angle measures 30 degrees with this side square root of 3 over 2 and this side is 1/2. So this is now the reference triangle, and this point with coordinates square root of 3 over 2 and 1/2. Again, this is equivalent to 30 degrees or pi over 6. For this point, this is equivalent to 45 degrees or pi over 4 with coordinates square root of 2 over 2 and square root of 2 over 2. And this point will represent the coordinates 1/2 and square root of 3 over 2 and equivalent to 60 degrees or pi over 3. And for this, we will have 90 or pi over 2 with coordinates 0 and 1. So, this is now the trigonometric ratios of standard angles. Angles in degrees or in radians, so namely from 0 degree to 90 degrees, equivalent to 0 rad until pi over 2 for 90 degrees. For sine, that is sine equals to opposite side over hypotenuse, it will give us 0 because the value of y is 0. And in 0 degree, the value of y is 0. That is why the value of the function is 0. And for cosine, it is the x coordinate, the value is 1. So that is why we have 1 here. And for tangent, that is opposite over adjacent. So that is 0 over 1 equivalent to 1. And cotangent, which is the reciprocal of tangent, so we have now 1 over 0, so it's undefined. For secant, it's equivalent to 1 because it's the reciprocal of cosine. And cosecant is undefined. For a 30 degree angle equivalent to pi over 6 rad, sine is 1/2. And why is it 1/2? Because it's opposite over the hypotenuse. The value of sine is 1/2 because here y value is 1/2. And for cosine, it's square root of 3 over 2. That is why we have square root of 3 over 2. For tangent, you just simply simplify 1 over square root of 3 and rationalize the denominator, so it will give you square root of 3 over 3. For cotangent, you have square root of 3. Secant, you have 2 square root of 3 over 3. And for cosecant, we have 2. And so on and so forth. Let us have now an example. Find the 6 circular trigonometric functions given theta is equal to 60 degrees or pi over 3. For the solutions, you have to determine the corresponding point of the coordinates xy on the unit circle. Now 60 degrees is in the first quadrant and corresponds to the point xy with coordinates 1/2 and square root of 3 over 2. And all circular functions have positive signs. So the answers, we have sine 60 degrees equivalent to square root of 3 over 2. Cosine 60 degrees is equivalent to 1/2. Tangent 60 degrees is equivalent to square root of 3. Cotangent 60 degrees is equivalent to square root of 3 over 3. Secant 60 degrees is equal to 2. Cosecant 60 degrees is 2 square root of 3 over 3. And if you would like to change this value into decimal, then you can have 0.8660. This one is 0.5. this is 1.7321. This value is equivalent to 0.5774. This value is simply the same, which is 2, and this is equivalent to 1.1547. Now, using your calculator, you can press these keys. For sine 60 degrees, just press sine 60 equals, it will give you square root of 3 over 2. And if you would like to change it to decimal, just press this symbol SD to get the decimal equivalent, which is 0.866025438. All you have to do is to round off your answer into 4 decimal places. And for cosecant 60, just press sine 60 equals, it will give you square root of 3 over 2. Then press the reciprocal function x to the negative of 1, it will give you 2 square root of 3 over 3. Then change this into decimal by pressing this symbol or key to get the decimal equivalent. And press this key, the SD key, to get the decimal equivalent, which is 1.154700538, and then round off to the nearest 4 decimal places. You can check the other values using your calculator. Example number 2. Find the other 5 circular or trigonometric functions given 7 pi over 4, which is equal to negative square root of 2 over 2. For the solution, 7 pi over 4 is in the 4th quadrant and corresponds to the point with coordinates square root of 2 over 2 and negative square root of 2 over 2. Now, since sine is equivalent to the y coordinate and the y coordinate is square root of 2 over 2, negative square root of 2 over 2, that is why you have here negative square root of 2 over 2. And this portion is the 4th quadrant of the unit circle. This is 7 pi over 4. And we have the coordinates square root of 2 over 2 and negative square root of 2 over 2. So for sine, 7 pi over 4, sine is simply equivalent to y. So just take the value of y, which is negative square root of 2 over 2. For cosine 7 pi over 4, that is simply equivalent to x, and the x value is square root of 2 over 2. For tangent 7 pi over 4, tangent is y over x, and y is negative square root of 2 over 2 all over square root of 2 over 2. To simplify, it is equivalent to negative 1. For cotangent, which is the reciprocal of tangent, so we have now x over y. So you just simply take the value square root of 2 over 2 all over negative square root of 2 over 2, which is also equivalent to negative 1. And for secant, 7 pi over 4, which is 1 over x, so that's 1 over square root of 2 over 2. Simplify, so it's square root of 2. And for cosecant, 7 pi over 4 is equivalent to 1 over y. 1 over negative square root of 2 over 2 is equal to negative square root of 2. Take note of the signs of the trigonometric functions in different quadrants. Since this is in the 4th quadrant, only cosine and secant are positive. For the 1st quadrant, they're all positive. 2nd quadrant, only sine and cosecant are positive. For the 3rd quadrant, only the tangent and cotangent functions are positive. So again, the answers are, for sine, we have negative square root of 2 over 2, so it's negative. Cosine, square root of 2 over 2, it's positive. Tangent, it's negative 1. Cotangent is negative 1. Secant is square root of 2, so that's positive. Cosecant, it's negative square root of 2. Take note again, for quadrant 4, only cosine and secant have positive signs. Example number 3. The point with coordinates negative 2 and 3 is on the terminal side of theta in standard position. Determine the exact value of the trigonometric ratios for angle R. So this is the illustration. This is the given theta, and the reference angle is represented now by R. This point with coordinates negative 2 and 3. So this is negative 2. This is 3. The opposite side of R is equivalent to 3 units. The adjacent side of R is equivalent to 2 units. Since the x-coordinate has a negative sign and the y-coordinate has a positive sign, it is found in the second quadrant. So only sine and cosecant are positive. First, we have to solve for the value of R. So using the equation of the circle, R squared is equal to x squared plus y squared. Substitute 2 to x and 3 to y. So that is equivalent to square root of 13. R is equal to the square root of 13. The answers, if you notice, only the sine and the cosecant functions are positive. Sukatuwa, wherein S stands for sine, O opposite, H hypotenuse, C cosine, A adjacent, H hypotenuse, T tangent, O opposite, A adjacent. Now in this figure, if this is the reference angle represented by theta, this is the opposite side. This is the hypotenuse, opposite of the right angle. And this side is the adjacent side of the reference angle. Now, you have to remember Sukatuwa in determining the circular or the trigonometric ratios. Sukatuwa is a mnemonic device to help you remember the 3 basic circular or trigonometric ratios to solve for the missing sides and angle in a right triangle. It is defined as, so for sine equals opposite over hypotenuse, ka for cosine equals adjacent over hypotenuse, and tuwa for tangent is equal to opposite over adjacent. And the other 3 are just simply reciprocals, so all you have to do is to take the reciprocal of the ratios. So again, using this figure in the given earlier, for example, you have sine R, which is opposite over hypotenuse, equivalent to y over r. Y is 3 here, and r is square root of 13, so it's 3 over square root of 13. And 3 over square root of 13 times square root of 13 over square root of 13, because we have to rationalize the denominator. And this is equivalent to 3 square root of 13 over the square root of 169. And 3 square root of 13 over 13, which is the square root of 169. That is why the value of sine r is equal to 3 square root of 13 over 13. And for tan r, which is opposite over adjacent, which is equal to y over x, the value of y again is 3. X is 2. That is why you have 3 over 2. Now, since this is in the second quadrant, so the value of tan should be negative. And for cotangent r, since this is the reciprocal of tan, all you have to do is to reverse or take the reciprocal of 3 over 2, and that is 2/3. And again, this is in the second quadrant, so cotangent is negative. So cotangent r is equal to negative 2/3. And for the other solutions, you do it yourself. So again, tangent is the reciprocal of cotangent, so the reciprocal of negative 3 over 2 is negative 2/3. Do you have questions? If there is none, see you next time. Bye!